Draft physics video. Unfortunately, a retake. Yes, yeah, I made an hour video and the camera failed. These cameras are getting kind of old, so they fuck up, which is irritating. So who knows? Maybe another hour worth of nothing. So anyway, I was going over the subject of the refinement of the overall theory, and most specifically related to bent space and time dilation, space-time, and that there's a very suitable replacement for this undefined field thing, this mechanism that they threw into what was supposed to be empty space. The word space was supposed to mean an empty place, not a place with a something in it that was bendable. And it's unfortunate that physics took this direction, and just like the ambiguous status of the photon, as if it has no place in reality and that it is doing some sort of whatever, deciding where it's going to go. And there are narrow decisions, not absolute decisions, as much as they like to play the game. That it has infinite possibilities. It really doesn't, and they'll never be able to prove one of those infinite possibilities as a reality. It always does something very narrowly probabilistic, and their excuse is we can't prove something that's so impossible. Well, obviously, right, they can't prove the impossible. I mean, the improbable. Because we can't wait long enough for the improbable to happen. But they say it would happen, and no, the point is it's not going to happen. So anyway, I'm already veering off the previous video, which was a pretty good video, which is irritating. Because I was quick and concise and energetic, and I'm not any of that today. But anyway, so the idea of bent space is just a, and then to throw time into it, just a huge mistake. The relationship between there's an obvious connection between the bent space idea, gravity, and the idea of acceleration, and the idea of velocity, and that having a velocity might alter your time in terms of how you function. So your metabolism could be slowed down as you became more energetic in one direction. The idea is if I've made this metaphor before, but it's a very good one. If you're dancing as fast as you can in one place, and I oblige you, request that you move in some direction as you dance, you won't be able to do as many dance steps. They'll be slowed down effectively. Even though you're dancing still just as fast from your perspective, you're taking time to move in the direction I ask you to move, and that time has to be subtracted from your normal metabolism. And the same thing is happening to matter when it gains a velocity. Its structure is changed by the event of velocity, and in turn it tells time differently in that it dances fewer steps per minute while it's moving. And there, now I've just taken a more structural example and made it do exactly what space-time does. So space-time is infinitely replaceable as a theory. It is not some perfect key going into the perfect lock and opening the door of wisdom. It's a very simple lock. The only two things you're trying to explain are a force that moves things together. Physics has concluded, wrongly, that this force is attractive, and the complex thing, pulling, the two things pull each other, and it's just another bad guess. And instead it's a pushing force, and the pushing force creates, through acceleration, velocity, if the things are allowed to keep moving in the direction of the acceleration. Now, in the case of orbits, they're not allowed to do that because the two velocities are opposed to each other. They're moving in different dimensions, and therefore one velocity negates the function of the other acceleration. So one of the accelerations is destroyed by changing the straight line into a circle. So yeah, so it's really not what people think. Like, oh, this explains it all. This is just so perfect. You know, this space-time nonsense. Time is a function. It's not a dimension. It's something that matter does as its process. The fact that it doesn't do everything instantaneously, that it takes time for a photon to go from point A to point B in a straight line, is the creation of time. And it's that simple. There's no dimension of time. There's no blah 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 woo 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 woo. None of that. It's just a fact of measurement, and that's it. You can measure it wrong if your ruler is broken, and if you're measuring it based on how fast it looks like the thing is dancing, well, then you're going to get the measurement wrong, because it's dancing slower because it's moving, and it takes time to move. Again, not complicated, really simple. Alright, so anyway, so the modification to my new version, getting, I think, tighter and tighter. The force of gravity is a particle force, and that there's all these little bits called quanta moving the speed of light. We don't see gravity, but just like it's doing exactly the same thing that light's doing. It's a force. It moves the speed of light, the bits in it. And just like electromagnetism, light, and gravity, they all move the speed of light. And they're just the fundamental element, the quanta, and that's what it does. It just moves from point A to point B in a straight line, and all these forces move in straight lines. That's why gravity obeys the inverse square law. It doesn't bend. It doesn't go around things. It doesn't curve unless it interacts with an electron and the electron changes its direction. I have gone over that, but I'll go over it some more, because this is the key function that confuses the quantum mechanics theorizers. They've ignored what was kind of established with the idea of quantum electrodynamics, the 1960s Feynman version of reality, where photons interact with electrons. Electrons move in a non-linear straight direction, and that causes the photon to gain a new direction because the photon is released in a new direction. Not complicated. No woo necessary. No bending of the quanta. The quanta don't bend. What bends is the relationship the quanta have to the electrons and protons that they affect. So as stated before, gravity is a nuclear force. It's affecting the little bits inside the atom, not the structure, not the body, not the earth, not the mass. Has nothing to do with the force of gravity. It's the little bits that are being affected by gravity. They exist in the real universe, space. Okay, there is not such a thing as the big universe and the little universe. There's one universe. Everything exists in it, and it's all made out of these little bits moving the speed of light. And what distinguishes this matter from the less material atmosphere, the less atomic structure, is the density of electrons and protons. There's more electrons and protons here than there is out here, and in space there's even fewer, very few. And that's the distinguishing factor. Now, that doesn't mean there's fewer quanta. It doesn't mean there's less amounts of this energetic particle. It just means that these are identifiably different, and I've called that polarization. These are, strictly speaking, the protons are all, say, red polarization, the electrons are all blue polarization, or you can think of it as plus and minus, 0 and 1, however you want to do the bit math. It's two things, two versions of the same thing, and what happens in matter is that the electrons are all of one version of quanta, the protons are all another version of quanta, and there's implications to how they affect each other because of that conflicting substance, form. So the three forces are all made out of this quanta. Light would be this quanta polarized at specific frequencies. So if you had a chain of pearls, the idea would be you had white and black pearls on the necklace of pearls. There would be a black one at specific locations, 1 inch away from each other. Every fourth pearl was black. That would essentially represent what a photon is. It doesn't mean there's not quanta in between of the opposite polarization. It just means there's an identifiable link of quanta at specific locations with specific polarization. And that affects electrons. Electrons are affected because electrons have a mechanism where they're existing in a pressure field, and that pressure field dictates their size. So all the electrons and all the protons have a standard size. They can't be half electrons, they can't be double electrons. There's no such thing as a half a proton and a double proton. They have to be a specific size because it's the specific pressure of the universe essentially that dictates their size. And I have attempted to explain that the mechanism is basically a back and forth mechanism in all directions. If you were to think of an electron as a spherical object when it's not moving, so when it has an absolute no velocity, you could think of it as a perfect sphere with rays going in all directions, and those just bounce back and forth between the pressure. So this might be worth drawing. And so we'll just use one color, I suppose, just to make it simple. But the electron would essentially be, its shape is sort of irrelevant, because what's really happening is this kind of thing. There's field pressure that comes in, and the field pressure would be the opposite polarization. So this would be all the pluses, and this you could think of as just minuses. So we just use zeros to, describe minuses. And this field pressure is a certain amount of regularity to the occurrence of this pressure. So there'll be one every 1/1,000,000th of a second or something on average. And so it's an average over time. And so what happens is the internal bits just reflect off each other. So we're back to this kinetic argument where, well, I guess I could redraw that because it is sort of significant. So it would be this idea that things reflect off each other perfectly. And you can't really tell when two of the same polarization interact. You won't see the interaction. You can't tell whether this went through that or this went through that, or whether they reflected off each other. And it's only when there are two things of opposite polarization that you can actually see that they do reflect. And so what's happening is this force comes in from the outside, and it's so what I have figured out, which is the new variation, is originally I was thinking that there had to be three types of polarization, a neutral and a plus and a minus, or a red and a blue. And the red would be, or the blue would be the electron, the proton would be the other, and so on. The neutron is, I think, a dipole. It's basically a magnet. It has both polarizations, and so it's perceived as a neutral, but it's not really neutral. It has positive and negative elements. But its overall effect is a zero relative to an electron or a proton. But it depends on how you orient it, of course. Anyway, let's concede something here from the beginning, is that they do all these measurements based on, you can't really measure an electron just like you can't really measure a photon, because you have to use stuff made out of matter to do your measuring, and it automatically interacts with the thing you're trying to measure. So you can't really measure the charge of an electron or the charge of a proton in anything called isolation or in a clean environment with a clean ruler. Your measurement's always going to be corrupted by the fact that you can't erase the charge on the matter you're measuring the charged particle with, and that's a huge problem in terms of trying to measure the size of these elements. But anyway, so the pressure comes in, and what's happening is these are all reflections. and absorptions. So when the red comes in, this the element moving this way ends up reflecting, and it goes back down this way, and then it reflects when it hits it. Now there's elements coming from this direction, and they hit it and knock it back this way. And so there's a balance in the field that constantly keeps all the elements moving. So the real shape of the thing is kind of just a bunch of rays moving back and forth in the 3 dimensions, would be the structure of an electron. And so in even field pressure over time, there'll be variation, like it'll move a little extra this way, and then it'll move back a little extra this way, because the field balances. There's always heads and tail balance. So even though this side's up 2 reds, eventually this side will be up 2 reds, and so it'll always end up balancing. So electrons are constantly moving in the sense that they're not in one location for any length of time. Their shape is always changing a little bit as the field energy's randomness is felt by the electron. But the point is over time, it ends up looking like this. It ends up having a profile over time that gets more and more static the longer you sample. So the longer you sample, the less this moves, but the shorter you sample, the more it moves. In terms of its actual state, is quite jittery, and you don't take the jitter away until you remove the frame weight. It's the same kind of law in video. Actually, the more frames you have, the more jitter you'll see. The less frames, the less jitter. Anyway, so then acceleration would be a circumstance where the same color comes in and it essentially lengthens. So if this is the arrow for the electron in terms of the average amount of time before it hits, and then the average amount of time it goes the opposite way and it hits. So when it is another blue interacts with a blue, what effectively happens is this line is now lengthened, and it means that it'll take a longer time to get to the other side. And as it takes that longer time to get to the other side before it hits something, it means that this field energy coming this way will end up encroaching. And so then on the rebound, it will rebound sooner than it usually does, because it'll hit this encroaching field energy, and so then it'll rebound further again into encroaching into this field. And then when it rebounds, it will rebound short again, because it's going to hit the field energy coming in sooner because of the lengthened amount of time. So the real movement of an electron is always something like this. Now obviously that can look like, to people who like to see waves everywhere, that looks like a wave, but it's really not a wave. It's a mechanical process, and the idea is that even though whatever extra comes in, whatever extra arrow comes in from the direction it comes in, that extra is always remembered, in that this is essentially always remembering that there's one extra arrow going this way, and it's always going to remember that one extra arrow. And so that's the definition of velocity. So the acceleration is the addition of the arrow, the velocity is the retention of that extra. And so until it meets a force coming from the opposite direction to negate that, then it can go back to balance again. And but that's the nature of velocity, is that it's not really a straight velocity. A photon doesn't go in and automatically move something a little teeny bit forward. It really jitters it in a forward direction, going back 1 step, forward 2 steps, back 1 step, forward 2 steps, kind of motion. And that's the partial of the absorption of the time. The thing that is really absorbing the time, though, is the fact that when you think about an electron, it would have say a 1 million quanta inside of it. And one little photon, one little quanta comes in this way to affect it. Well, it's actually 2 quanta, really. And the 2 part is essential to creating this forward vibration, but I don't want to get into that part of it, because any quanta will create the effect, any number. But anyway, all right, so you have 1 million of these, And the thing is many of them are going in directions that don't have anything to do with moving forward. And all of those bits have to essentially be moved forward. They have to be moved up. So they have to be moved in the direction of the velocity. So all the elements not going in this direction have to be moved up forward, with each instance of any kind of thing called velocity. And so this one bit of movement at the speed of light has to be spread over the entire mass of all the quanta inside of the electron before the electron actually starts moving. So the electron moves 1,000,000 times slower, you could almost argue, than the photon that affected it. And you'd have to obviously push a lot of photons into an electron to accelerate the electron to a very fast speed. But many of the things that they measure as electrons moving at a fast speed are really just the quanta moving between electrons. So electrons can essentially just communicate movement between them. This one gets hit, it moves maybe a little bit, and then it just sends the force to the next electron, moves it a tiny bit forward, and then this one moves the force ahead of it. So it appears like there's an electron moving, but it's really not. It's just this electron communicating with this electron, communicating with this electron, and just moving them a little bit, and it has the illusion of movement of the chain of electrons, but all that's really happening is the force is being transferred from electron to electron to electron. Kind of like if you can imagine just static magnets. If I had static magnets stuck in a field, so there's a center magnet, they're all the same polarization, none of these magnets can move. They all get kind of in a frozen because they have a balance with each other that won't allow them to go in any further, because then they have to get closer to these other repulsive magnets. So even though this is the plus and all these are minuses, so there's an attraction to the center, but it can't break this bond between these two repulsive forces. It can't overcome them to go in. So these are all in a locked relationship. You know, if you can do some of this in real with real material magnets, but the problem is they always flip or they move, so you have to put them between glass or put them in an environment where you stop them from turning. But so simple little ways of fixing them so they can't flip their polarization and then cheat. If you can prevent that, you'll see this effect. And I could just move this, in that field, I could just move this positive charge anywhere I want to, and these negatives will all stay balanced around it. But regardless, I don't want to get into the physics of magnets in this video precisely, but I just wanted to get the idea that I could push one of these magnets, give it a force, and what will happen is this magnet won't go spinning around. What it'll do is it'll push on this one, and this one will 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 push back on. And so it will appear as if I initiated some sort of movement, and all I'm really initiating is a push that creates movement in all of the other magnets. But they all tend to find a balance again in whatever new position. You know, it'll be exactly the same balance. The fields always are balanced. They're forced to be balanced in the end. Conservation and such. Alright, so velocity is so as the electron is accelerated, so I've explained this before, but this is where all the bending of light takes place, is in these electrons. And as stated before, they're in fields. They're always find a neutral field. Or an electron, if it's not moving, it means that it's found a balance between all the positives around it, and it's found a balanced location. If there's any imbalance in the positives around it, it will move and change its position to find that balance. So any electron that's in any place that's not moving is not moving because it's found a balance between all the charge fields all the way around it. It's in a balanced field. And if you imbalance that field, with force, obviously it's going to be changed in terms of its movement. and it'll gain acceleration. And acceleration is really the consumption of an arrow. So a bit of quanta, a little extra comes from one side. So you have 2 from this side, only 1 from this side. And this essentially changes the shape of the electron and in the direction of its movement. It'll get thinner in its width, because what's going to happen is it's going to lose the bits on the outside. So there's, say you could understand that there's a shape dynamic. It's probably not the best to draw it this way, but the one that's most perpendicular would be the longest line. So you could sort of understand that even when you draw it, it always comes out looking a little shorter, the transverse ones, the ones you do traversing another dimension. So the widest one is the one where when this stuff starts moving in this direction, this widest, the line that's most perpendicular is the one that's going to be most likely to be broken, in the sense that the energy of the overall the adhesiveness between the elements inside of the electron is going to get weaker as it moves away. So it's kind of like, I guess you could do it with a spring idea. No, that's probably not going to make it very visible. But the idea is that if this creates a tight bond, if I move the circle, oops, boy, that's just terrible. It's jittery. If I move it away further, if I move this away from this distance gets further and further, and eventually there'll be no connection between the two. There won't be enough of a bond to hold that bit in, and so that bit will be released in the direction it was going. So in a sense, it won't keep doing the back and forth thing. It'll end up being a vibration in one direction that won't be part of this body anymore. So as the electron moves in one direction, it's encountering more field in the direction that it's moving, but again, it's not a friction field because all the interactions are just perfect reflections. They don't steal any energy, they just cause more reflections in the direction of the movement. And so there's no friction, and the thing that's being reduced is the amount of elements going in the opposite direction that have to be moved with it. So as you move something, it's encountering more force forward, but in a sense it has less bits perpendicular to have to change because it's releasing those, and so that's EMF. So when an electron moves or is accelerated, it releases elements perpendicular to its movement. So everything in the plane, in the other 2 dimensions of the opposite the dimension you're moving in. So you're moving in one dimension, the other 2 dimensions are on the same plane, the left, right, and these 2 dimensions. These 2 dimensions are on the same plane, and those 2 dimensions release the what's called EMF, or electromagnetic radiation, which is just quanta. It's like photons, and they move perpendicular to the direction of the electron. They're radiated out perpendicular as it gains acceleration. So acceleration causes the disposal of the thickness. So things get thinner and thinner in the direction they're moving the faster they go. Material bits, protons and electrons, lose mass in the other dimensions as they move in one dimension. So the dimension they move in, they gain mass in as they're accelerating, and they lose mass in the other 2 dimensions. That's why things moving will bore holes in you, is because they're more massive in the direction they're moving, like a bullet. So a bullet with velocity is really all of its mass is being converted, or a portion of its mass is now converted into the direction of the bullet's going, and so it's much more massive in that dimension than it is in the other dimensions. It's becoming more and more invisible in the other dimensions, and if you move the bullet fast enough, it would be essentially transparent. It would have it would no longer have mass, it would no longer reflect energy in the dimension perpendicular to its velocity, and it would essentially be a photon, a group of photons. all moving in the same direction. So again, this is all just polarization. It's all the same amount of energy everywhere. There's as much quanta here as there is in the air here as there is in empty space. It's just this matter is polarized, and that is it's made up of electrons and protons that have segregated the field polarization into those objects that are the likely consequence of being an electron is that the quanta are probably closer together and all have a common direction, and so when one bounces, it just bounces into all the others, changes all of the others' direction, and then the same thing happens when one bounces this way, it changes the direction of all these in the same direction. And it's a cascading effect, but that's really all it really is. It's just a collection of polarization. Alright, and so that's what's creating the gravity. The gravity is affecting that. And the gravity is made of both an even balance of the red and the blue. The electrons are all blue, the protons are all red, and because of that circumstance they interact with each other in the sense that they are attractive and they repel the one with the same color because the reflective force. So I'm not going to really explain the reflective force, I just wanted to explain the induction of gravity, because that's relevant to the bent space argument. So the idea is the field energy, and so let me just take two gravitational bodies, and just for the sake of this argument I'm going to propel this one by some explosion or whatever, so it gains acceleration in this direction towards this gravitational body to move into the field in a relevant way, in a way where they're really starting to exchange accelerations, and that's really all it is an exchange of acceleration. So when this body accelerates, what's really happening is this energy goes into the electrons of the thing that makes it up, and the protons, and it has to move all the quanta inside every proton, and all the quanta inside of every electron has to be pushed in the direction of the movement. So for it to move, all of the bits have to be moved, even the ones going the wrong way, technically. Obviously that exact same bit won't move, but the idea of the bit will move. The position of the bit will move. All this stuff is constantly exchanged. There is no quanta that goes from point A to point B, really. What's really happening is a bit of direction goes. So it's like the kinetic balls. They're not, if you put enough of them together, just the energy goes through them. You can sort of see the directionality comes in one way and pops out the other end. But anyway, I don't want to confuse the argument. So you can sort of understand that for this thing to move in this direction, it's going to take 1 million times for every single element. There has to be a force initiated. It'll take 1 million times. Now, if this has to move, and then this has to also change the field around a proton, then it can be 10 million times longer for this energy to actually create movement. So you can sort of understand if the force is small, the movement will be very slow, because it's going to take it a long time to move all of the parts inside in the direction of the movement. So 1 second goes in, and 1 year of movement comes out, kind of thing. It'll take a year in the sense of an energy comparison. It'll take a very long. The light's moving very fast. The matter's going to move very slow by comparison. But the point is that this absorbed the polarization of the force, didn't hit here. So something that was heading for here doesn't get there because it's taking a long time to move this matter. So a great deal of time interval. There's no these arrows don't get. They should be here at a specific time. They're not there because they're still moving this matter. So this element feels the absence of the force. So there's unforce here. So maybe I'll draw that as a backward arrow. And obviously the field energy on the other side is still the same. And so this absence of energy coming from this side means that this object is now going to have more arrows going in this way, which it's going to be accelerated by. It's going to be obliged now to, those arrows will move this object in this direction, and by the same process it has to move all the bits inside of it, and that's going to create a lack of force on this object going this way, which is going to accelerate it. So it's induction. So it's just like electrical induction, magnetic induction in wires and conductors. Gravity is the same kind of inductive force. The Earth moves towards the Sun. That causes the Sun to move towards the Earth. The movement towards the Earth creates a shadow, creates a lack of force getting to the Earth, so the Earth moves forward again, and they just keep feedbacking their acceleration into each other. And obviously, because the Sun is so massive, the Earth can't move it very much, so we don't see the movement, but it actually is moving. And because the orbits are circular, obviously the net effect over a year is you move the Sun this way just as much as you move the Sun that way, and so it all evens out in the end. But at any one point, the Sun is moved a little bit because of the position of the planets, and it moves the other way, and it moves like an electron. It's constantly being moved in its position based on the arrangement of the bodies affecting it gravitationally. Alright. And so as the things gain acceleration and move faster and faster, then they get the velocity thing, and then that causes the time dilation thing, and so that's your bent space. So you don't need to create this artificial bent field. All you have to do is understand that the field energy is being shadowed, and that's creating the same effect, and because of the velocity created, the velocity creates this lack of ability to dance as fast, which means that essentially the matter is cryogenically slowed down because all of its processes have to slow down. All of its relationships are more complicated because of the fact that it's got to move, constantly be pushing more and more bits going the wrong way. It's got to move all those bits going the wrong way, the way it's gaining acceleration or velocity. And that process is time dilation. And so the two of them are tied together in this physical way, not tied together because of some space-time field that exists. There's no space-time field. There's just quanta, and there's the effect on matter when you accelerate it or give it velocity, that the matter's metabolism slows down. Now the inverse square thing, where the field is slowed down, can be understood as these forces that I've been using. The real idea is that the dimensions are you always have to understand them as real dimensions. The forward dimension and the back dimension are two sides, two planes to the one dimension of forward and back. But any movement in the forward direction is forward, and any movement in any direction in the reverse is the reverse. So this is like say this one would be a 10 in terms of a perfect dimensional movement, and this would be a .001 dimensional. It would only have .001 of an element in that direction, but any element is a real element. So you can sort of understand that when the Sun moves, it could move this way to represent moving this way, because there's an element of this in this. Okay, when you go this way, there's two elements. There's this direction and there's this direction. And so there's always an element of the right direction. It just has to move a little further if it's going to use this as the only way of acquiring this force. But the point would be is that it's all 2%, 2%, 2%, 2%, 2%. So this is the weakening of the force between two things. So you can just understand those as field lines. It's a way of describing it. So you just evenly space the lines. And as you're further away, you're getting hit by fewer lines. And as you're closer, you're getting hit by more lines, so the gravity is stronger. But it's exactly that same effect. The more lines you get hit by, the more lines you intersect, your mass is intersecting, the more force, the more gravity. The fewer lines, as you get further away, less and less lines can affect you, there's less and less force. And that also will explain why bodies in orbits Obviously, when they're getting accelerated down, it takes a long time for Pluto, say, at the speed of light, it takes a long time for the force to be affected by the sun, and for the sun to move, absorb force, and then for the force to get back to Pluto. But the point is, and so Pluto would be in an entirely different position by the time the gravity showed up. But the point is when this Pluto is creating gravity, it's creating it in this entire plane. And so this whole 180 degrees is where there's more gravity. So when it's causing an inductive force here, it's actually causing an inductive force in all of these positions. There's just no matter to be pulled in by them. But technically, without the mass, there is no gravity. The gravity is created by the mass accelerating, and the counter-gravity, the responding gravity, the thing that makes this have gravity is the reaction of the body it's connected to. So it's all inductive. So theoretically, if there was a sun and there were no planets around it, there would be no gravity being created by the sun. The sun's gravity is only really a consequence of things actually changing its acceleration that aren't just the random field, because it's all inductive. Yeah. And so it's not until something enters the field that the gravity is created, but it's not directional. It's not a laser beam. It doesn't go straight back and forth instantaneously, and because it's not instantaneous, it's not a laser beam, so it ends up being spread over the entire dimension. I didn't explain that perfectly, but you can sort of get the idea of why forward motion isn't something it thinks about. It just thinks about motion in the direction of that dimension. And so anything that has that motion will be counted as I filled the quota. So you can fill the quota of this way by doing 4% this way and 4% this way and 2% some other way. And that would fill the quota of this much energy in this direction, of 10 in this direction. Right, so that's, I don't think I need to do anything more. This was the previous videos. Just as bad drawing right. Yeah, it's kind of funny. I don't know which one's worse. But I think it's all the same stuff in there in terms of understanding that you don't need imaginary, theoretical, invisible, attractive force things. Again, it's completely a push force. The universe runs on push. Things are pushed into other things, and the only thing that makes the whole thing work is that there's a segregation of polarization of color. And when you segregate color, you end up doing this thing, where you can't tell this reaction. You can't tell whether they just go through each other. This reaction, you tell there's a change in the universe. And likewise, if there was a head-on collision that creates this effect, you wouldn't be able to tell whether it just went straight through or whether they bounced off of each other. But if they have opposite polarization, if this was red, you would know that the red bounced off. So red was coming in, red went out, blue was coming in, blue went out this way. And that's the key to this whole thing. And that's the nature of the attractive and repulsive forces of magnetism, and what appears to be an attractive and repulsive force in gravity, but attractive force in gravity, but it's completely a push force. It's the blocking of energy, the blocking of polarization of a specific kind that moves bodies together. Alright, so I think that's probably enough for this video, and hopefully it recorded successfully, and then I can move forward to the next installment. Oh yeah, I did want to do, somebody posted a couple of raggy comments on the comment board, and to these stupid raggy physics. So this first one is, first ever photograph of light is both particle and wave. This is such a fraud. This is not a photograph, it's a computer simulation. It has nothing to do with seeing anything. So what they do is they take a beam of light and they hit a tiny nanowire with it. and obviously that creates electric current in the tiny wire, and so the electrons are moved. When the electrons are accelerated, they give off this EMF, as I was saying. This perpendicular polarization is released. And it's released as magnetism. Magnetism is photons. That's what they're confusing this with. But anyway, it releases this radiation, this energy, and they're shooting electrons along the edge of the wire and then measuring how much the electrons are moved. Well, obviously the electrons are going to be moved based on how much the electrons are accelerating in the conductor and the EMF is produced. And yes, it's going to have lots of variation in it dependent on how the electrons move through the conductor. But the point is there's what they're taking a picture of is how much movement the electrons are doing, which is indirect to what the photons are producing. But it's nothing like a photograph of anything. And the fact that they just synthetically colored this and did this, this is not a photograph. This is just pseudoscience. It has nothing to do with anything real. It has nothing to do with proving any wave nature of light. Light has no wave nature. Again, it's the electrons that have the wave nature in the sense that they create the wave nature. So again, let's understand, this is stuff known back in the 60s by Feynman. Okay, a photon comes in and it hits an electron. If the electron's not in a field, that is, there's no strong field that's going to influence it or force it to move in a direction, and it's free to move forward, it will move straight forward. And then when it releases its photons, it will hit another electron, move it forward, and whatever is the last electron will produce the photon in the same direction the photon comes in. So a photon comes in this way, it leaves this way. Now if the electrons are in a field, that is, there's some protons around, then the electron, when it moves, when this photon hits it straight, the electron's not going to move straight. It's going to move this way, like an orbiting body. So like the Earth, if the Earth had an arrow in front of it, you could sort of understand that its velocity is always in a straight line. It always wants to go in a straight line, and extra force comes in and moves it in another direction. And so it's all straight lines, though. It's all geometric. It's all in straight vectors, but it looks like a circle in the end. But it's not really a circle. It's a bunch of straight line vectors, and that represent a curve. But there's the light itself. The planet isn't moving.